random processes and the law of large numbers. Our objective here, we want to define random processes and the law of large numbers. So we're kicking off looking at probability, and we do that through starting off with this topic. To begin, what is a random process? Well, as you might imagine, a process that represents scenarios where the outcome of any particular trial, for example, the flip of a coin, of an experiment is unknown, but the proportion or the relative frequency a particular outcome is observed approaches a specific value as the number of trials increases. Okay, let's look at flipping a coin. We'll speak of this a couple of times here. We know that your outcome of getting a head is 1/2. The outcome of getting a tail is 1/2. Okay, so a random process, the proportion or relative frequency a particular outcome is observed. So let's also define probability, since this is what this is all going to be about. Probability is a measure of the likelihood of a random phenomenon or chance behavior occurring. Okay, probability deals with experiments that yield random short-term results or outcomes, yet reveal long-term predictability. Back to our coin flip. We could have a head, a head, a head, a head. We have 4 heads in a row, but we know that over the long term, we're going to wind up with half heads and half tails, or very close to that, even though we just had 100% heads in the example I was just talking about. The long-term proportion, probability, the long-term proportion in which a certain outcome is observed is the probability of that outcome. The long-term proportion. Okay? Again, back to the heads and tails. Just because you saw 4 heads in a row and you stopped, that doesn't mean the probability flipping a coin of getting a heads is 1. Okay? Over the long term, your heads will come up 1/2 of the time, your tails will come up 1/2 of the time. And finally, probability is expressed as a decimal or a fraction between 0 and 1. The fraction, of course, will be a proper fraction, or as a percent between 0 and 100. Okay, let's talk about this law of large numbers. Back to our coin. In flipping a fair coin, we say that the probability of observing a head is 1/2, or the decimal 0.5, the percent 50%, because as we flip the coin more times, okay, long-term proportion, the proportion of heads that come up tends toward 1/2. This phenomenon is referred to the law of large numbers. Okay, stated down here, as the number of repetitions of a probability experiment increases, the proportion with which a certain outcome is observed gets closer and closer to the actual probability of the outcome. Again, back to our heads, tails example. If your first 4 are heads, okay, that's obviously not 1/2, but as the repetitions increases, you flip the coin 100 times, 200 times, 1,000 times, 5,000 times. The probability of a head gets closer and closer to the probability that we expect, which would be 1/2. Okay, let's look at a couple other definitions that go along with this. Let me turn my other paper over here. Okay. In probability, you have an experiment. Okay, an experiment is any process with uncertain results that can be repeated. Okay, the sample space, which we use the letter S for, capital S, of a probability experiment is the collection of all possible outcomes. Head-tail example, your sample space is head and tail. There are 2 possible outcomes. An event is a collection of outcomes from a probability experiment. An event consists of one outcome or more than one outcome In general, events are denoted using capital letters, such as the capital letter E. So probability of an event. So for, which is probability of an event, something like that. Okay, just a couple more, obviously some definitions here, a couple of examples making use of this. A probability experiment consists of rolling a single six-sided fair die and then flipping a coin. Determine the sample space, okay, of possible outcomes using 1, 2, 3, 4, 5, 6 for the die outcomes, and HT for the coin outcomes. Well, we'll go with S for sample space, and I'll put a little ticks on it so it doesn't look like a 5. My S's tend to look like 5s. The sample space, well, a 1 and a head, or you could get a 1 and a tail. How about a 2 and a head, or a 2 and a tail? How about a 3 and a head? Whoops. You roll a 3 and you flip a head. You roll a 3 and flip a tail, and you can see where this is going, so I'll just continue. 4 tail, 5 head. Sorry about my 5s. A 5, that's better. 5 tail, and finally a 6 and a head, or a 6 and a tail. There's your sample space. My type writing is not very clear here. There's your sample space. These are all possible outcomes of rolling a single six-sided fair die and flipping a coin. We'll just make a note. This is 6 possibilities. This is 2 possibilities. And 6 times 2 equals 12. 12 total outcomes. We'll make use of that later. Second example, making use of this vocabulary and this idea. Let the sample space for equally likely outcomes be 1 through 10. So let's say you have a 10-sided die. Perhaps you're playing Dungeons and Dragons. You have a 10-sided die. And they all have an equal chance of, when you roll it, of being the top number, the number that comes up. Compute the probability of the event E, which equals an even number less than 9. Okay, probability of event E, which is the probability of an even number less than 9. Okay, what's the probability of an even number less than 9? Let's go to here. Here's 9, will be less than 9 and even. I'll just circle those. We know there are 2, 4, 6, and 8. There are 4 even numbers that are less than 9, and there are 10 total possibilities. Express your answer as both a fraction simplified as necessary and a decimal. Well, here's my fraction simplified, and as a decimal, this is 4/10. And I'll also include the percentage, and that's the same as 40%. So that gets us started a little bit with probability, the law of large numbers, as well as sample spaces and events.